So to wrap up our chapter on whole numbers, we're going to do topic 3, part 2, which is understanding order of operations. And in this part, we've already looked at just solving the order of operations or simplifying expressions with multiple operations. For this part, we're going to look at word problems, okay? Now, remember, when it comes to calculator usage, I'm not generally opposed to calculators in the right context. So there's a time and a place for a calculator. Problems like this, as long as you can show me your setup, a calculator is okay as a tool to help you, okay? But you do need to show me your setup and make sure you tell me what you're telling your calculator to do for you, okay? So again, word problems with order of operations. So the directions here, for example, 5, say solve each problem, include the correct units with your final answer. Remember to describe your answer when there's a word problem, okay? So for part A, you went shopping today where you bought 3 shirts at $15 each, 4 pairs of socks at $2 each, 1 pair of shoes for $56, 2 pairs of jeans for $29 each, and 2 sweaters for $20 each. If you give the cashier 5 $50 bills, how much change will you get back? Write a model to represent this scenario. So when we say something like write a model to represent this scenario, we want you to write a single problem that will solve this situation. So we want one single expression, mathematical expression that would solve this, okay? So let's think about this. We're giving a cashier a certain amount of money. From that, she or he is going to take away what we're buying, and then whatever's left over is the change that we get back. So let's think about that. So we're giving the cashier 5 $50 bills. So 5 times 50 is the amount of cash that we're going to give the cashier. From that, they're going to subtract the grand total of everything we bought. Okay. We bought a whole bunch. So we bought 3 pairs of shirts. Wow. 3 shirts at $15 each. So you just do 3 times 15. We got 4 pairs of socks at $2 each. So 4 times 2. Let's see, 1 pair of shoes for $56, so we can just add $56 in here. 2 pairs of jeans at $29 each. 2 sweaters at $20 each. So this right here is everything we bought. And this is the cash we gave the cashier. So if we take the cash we give the cashier, subtract the total of our purchase, that equals the change. So that's going to equal the change we get back. So as far as writing a model to represent this situation, this right here would be a completely acceptable model. So this is what we're looking for. Now from here, you need to show us a little bit of work. So for example, I don't want you to just type this into your calculator and hope to get lucky with what the answer is. Give us a little bit more than that. So for example, 5 times 50 I know is $250. So that's the amount of cash we're giving the cashier. Now let's figure out how much we spent on each type of item. So we got 3 shirts at $15 each. Well, let's see, 3 times 15 is 45. We bought 4 pairs of socks at $2 each, so that's $8. So 45 plus 8. 1 pair of shoes at $56, so 56. 2 pairs of jeans at 29. Well, let's see. This is where estimation is really nice. So 29 is almost 30. 2 times 30 is 60. So we spent almost 60, but each pair of pants was $1 less than that. So that would be 60 minus 2, so 58. Now, if you need to do 29 times 2 off to the side, you could. You could also use a calculator, but the more you do by hand, the better you get at this. So 9 times 2 is 18. So keep an 8, carry a 1. 2 times 2 is 4, plus the 1 we carried is 5. So that's another way you can get the 58. So let's see. Then we got 2 sweaters at $20 each. So that's a grand total of 40. So let's see, that's 250 minus. And at this point, I think this is when it becomes reasonable to use a calculator, okay? You could certainly use a calculator for those little multiplications in between, but you really do need to stretch your brain. You need to like make your brain work. That's how your brain gets better and learns, okay? So don't just cop out and use the calculator for everything, okay? So I'm going to use just my regular calculator that's here on my table instead of switching back and forth. So let's see, we have $45 spent on shirts, $8 on socks, $56 on shoes, $58 on jeans, and $40 on sweaters. So we spent a grand total of $207. on clothes. And if we can find the difference in 250 and 207, that's the amount of change we get back. We're living in a world where we assume there's no tax. Now, of course, if you went to like Old Navy or somewhere, there's going to be tax. You're going to pay more than 207, but we're pretending no tax. So let's see, off to the side, 250 minus 207. Well, let's see, I can't take 7 from 0, so I'd have to borrow from the 5. So 5 becomes a 4, 0 becomes 10. 10 minus 7 is 3. 4 minus 0 is 4, and then 2 minus 2 is just 0. So we would finally say that we get $45 back in change. And there you have it. Okay, so yes, a calculator is useful. Yes, a calculator is a tool, but still expand. Make your brain work, okay? Do a little bit. Don't always just go to the calculator because a lot of this was really easy stuff. So once we got to the point where we had, I think what, 5 numbers to add? Yeah, sure. Take a shortcut, use the calculator, but try to do some of this by hand. All right, finally, let's see here. So for part B, a farmer milks his cows twice a day. This morning, he got 376 gallons of milk. This evening, he got 382 gallons of milk. If he plans to sell 554 gallons to a local ice cream store, how many gallons will be left? Write a model to represent this scenario. Well, we want to find the grand total of gallons of milk that this particular farmer was able to get from his cows. So we know that the total milk for the morning was 376 gallons. Then there was 382 gallons from the evening. So that's the grand total of milk that this particular farmer got for this day. He then sold how many? 554 gallons. So if he sold them, he's going to reduce his stock by 554 gallons. This would be the model. Whatever we get here is going to be what's left over. So just like with part A, this question says write a model to represent this scenario, figure out how much milk the farmer has total, and then subtract what was sold. So let's do a little bit of work here to the side. Since we're just doing addition and subtraction, I feel really comfortable just doing this one by hand. So let's see, 376 plus 382. We're going to line them up vertically and then add column by column. 6 plus 2 is 8. 7 plus 8 is 15, so I keep a 5, I carry a 1. And then 3 plus 3 plus 1 is 7. So that tells me that this farmer has 658 gallons of milk total, but they're going to go and sell 554 gallons. So let's see what we get when we subtract. So let's see, we have 758 gallons. We want to subtract 554. So we line this up vertically and then we subtract column by column. So 8 minus 4 is 4. 5 minus 5 is just 0. And then 7 minus 5 is 2. So this gallon, good Lord, it's late. This farmer will have 204 gallons of milk. So 204 gallons of milk will be left over. So there you have it. That's the order of operations. Make sure you show the model if you're asked. Sometimes you'll be asked, sometimes you won't. Show us at the very least a setup. You got to show us something so we know what you're telling your calculator to do. And don't overuse your calculator. Try some of this by hand. If you've got a really nasty, complicated problem to work, sure, use your calculator. But if it's something really basic, like some basic addition or subtraction, try it out, okay? See what you can do by hand, and then use your calculator to check your work, all right? So there you have it. That's it for whole numbers. This wraps up our whole chapter. Make sure you have a general understanding of the order of operations, okay?